homework or lectures? Aaron.
3.1, 15, and 17.
15 and 17. The equation of the motion, the velocity and acceleration of this, the acceleration after 3 seconds, acceleration when the velocity is 0. Okay. 15. This is the motion. When they say motion, it basically means s is the displacement. Or let's say distance, however you want to call it. Okay. Which also tells you that the velocity is going to be the derivative with respect to t of your displacement, and your acceleration is going to be the derivative of your velocity with respect to time. Is that okay? Now just take the derivative. All right. So the first two questions are this. Oh yeah, minus 7.7. Okay. So that's the first question. What is V and what is A? This is how you do it. Second part, the acceleration after 3 seconds. That's going to be your A, but you plug in 3. So that's going to be 1.2 times 3, which is 306. They're not asking for a unit, so we are fine with it. Number C, the acceleration when the velocity is 0. To do that, you just need to plug in A, t equals 102 times t. You just need to put in the corresponding time. Okay? The problem here is, what is the time? Well, that happens when your velocity, which equals this, equals 0. That's how we are going to solve for t. Okay, from here you can see t equals plus minus square root of 7.7 divided by 51. Still okay? Cool. And then plug this one back. Clearly, we need to take the positive one because t is bigger or equal to 0 by the thing. So at is basically a square root of 7.7, 51, which is 102 times that. I would say for web work, you can just plug this one in. For our class, you can also plug this one in. Technically, in the exam, you will never see some number which is as bad as this. But if it is, you just keep it that way. Sounds good? Well, let's look at 17. Oh. Find the points on the curve y equal and 5x squared. Okay. Where the tangent is horizontal. All right. We're trying to look for points satisfying a certain kind of condition. The condition is given by tangent is horizontal. How do you translate that? Tangent, the slope of the tangent line is going to be 0 if it's horizontal. And that implies f prime x equal to 0 will guarantee the tangent line is horizontal. So it transfers to f prime x equals 0 and solve for x. That will be our point. The rest is just solving this. Hopefully it's a nice number. And it's not. So I hate this, but we need to do it. You have 2 points. These are the x values. Sounds good? Okay. Use a calculator to do it because for this case, you need the points. That means not only you want the x, you do want the y. And there's no better way other than just plug this x back in, and it's too complicated. So better use a calculator. Only for this one though, to find this and that. All right, that's 17. Sounds good? Cool. Nick, what do you have?
3.1, number 20.
Differentiate the function this. Okay. To do things like this, number one, you should realize this is supposed to be easy. It's just a power. The hard part is those powers looks confusing. Okay, so in order to find u prime t, let's rewrite this one into power first. What is square root of t in terms of power? 1/2. What is cube root? 1/3. Still okay? What about the 13th root? That's going to be 1/13. Second. No. 13 is hard. What about t to the cube and then square root? How do you do that? That's t to the cube to the power 1/2, which give me t to the 3/2, which means cube first, square root later. What about I change this to 13? It's all right. If that is okay, the rest should be easy then. Let's take the derivative. No. Okay. This equals that. This is 1 over t to the 12 over 13th root. In our class, again, don't need to do this. Just keep things in this way. It's nice enough. All right. Cool. Anton?
Actually, that was gonna be my question too. I had actually one more question though. What was like the average score on the test, if I can ask?
Can you guys see it? I know it's somewhere, but this camera system is amazing.
Oh,
I mean, I know it's somewhere. The thing here is, let me figure out. I mean, Commerce is beautiful. They hide the score somewhere, so I tried it for 3 semesters, still couldn't find it easily. I miss D2L. Yeah,
I
just
found it 66.4.
66.4. That's different from what I got here.
Oh,
So
that's what mine says.
So you can see it, right? Then trust yours. Yeah, I don't know if I am looking at the right place. So yeah, it says like for me it's like 64.4 and the low. I mean, maybe I think the thing with my system is they counted the people who didn't take the exam to be 0, because which is lower than yours. So it says low is 0%, high is 100%. So yeah, roughly so 66 is roughly the average, I would say. Any other questions, Anton? Cool. Zach, what's your question?
3.1, still number 9.
Aye. Oh, differentiate the function. No, 15. Yeah, currently we have two way of doing it. The first one is just, there's no shortcut, just follow everything out. X is 50x minus 150. That's certainly one way. Okay. But now if we have the product rule, it's actually, there is another way. That is, that's a product, right? The square. So differentiate the first one, keep the second one, keep the first one, and differentiate the second one. From here, we can have negative 10 times this, which also give you 50x minus 150. And we really don't have a preference. Do it whichever way you like. Later, we will have another one, which is called the chain rule, which can also handle this. So looks good. All right. Adam, do you still have a question or?
No, I don't.
Okay then. Yep. As we introduce more and more rules, you will see the way we do stuff can be easier and easier because we have more tools. So far, it's still limited. Okay. Other questions from the homework? Then let's continue. 3.3. Trig. We did a whole bunch of stuff to prove this, but finally it worked. Once it worked, we did it ourselves by doing the quotient rule to find all the other 6. Every time I do things like that, you should start to write with me without looking at what I write. So gradually, you'll memorize all these formulas. Cosecant. Cotangent x corresponding to this with a negative sign and change all the functions to cofunctions. So we have a table. We did it ourselves. Memorize it. We did several examples. You find it's really no big deal. As long as you know the table, it's done. One last thing. This has something to do with the fact. The fact is this. We got this fact through the proof of the derivative of sine x is cosine x. That's how we got this one. Remember, we draw the half circle, did the squeeze theorem. It's a long thing. But eventually, we know this is 1. This one doesn't look so special, but it turns out later, especially if you're going into physics. This is actually a very important fact to know. Okay, so depending on what your major is, if you're doing physics, you will see this fact actually a lot later. Okay, so for our class, we just take it out, give you some exercise, and that's it. We cannot show you why this is important. But what we can show is it can solve a certain type of problem. The problem look like this. Find the limit, x goes to 0, sine 2t, sine 8t. You're trying to compare the changing rate of two waves at 0. Okay, plug in 0. Of course, you have 0 over 0. This should not be t. This should be x. 0 over 0. Okay, you try to cancel some term. There is no way you can cancel terms. So what can you do? Well, this is what I observe. This is 1, right? What about this? What's the limit? Also 1. Why? Because this is 1. I just changed the x to be 2x. It should be still 1 because you still go to 0, right? What about this? Well, do they look the same? They're exactly the same. As long as they're exactly the same, the answer is still 1 because of the identity. Make sense to everybody? Okay, so this is actually a neat technique. That is, if this thing here and this thing here, one with sign, one without sign, and x goes to 0, then it's always 1 as long as these two match. Sounds good? All right. With that in mind, let's create what we want. Here's a sine 2x. I really don't like that. I want a 2x. Why? Because then this is 1. All right. You still have a sine 8t, 8x. How do you handle that? You just give it another 8x. If sine 8x over 8x is 1, what if you flip it? Still 1. So this is 1. Okay. Of course, is this one the same as what we had before? No, we added a 2x, we added an 8x, then you better get rid of it. So when you cross them out, you realize I still have the old thing. I just added more terms. Okay, and some of them help me to get rid of some of the terms, but still. Sounds good. What's the final answer? 1, 1, and whatever that limit is. In this case, 1/4. So with that fact, we were able to handle something which looked like this. The key is whatever in the sign, you just match it. Okay, you keep matching, you keep matching, you keep matching, and then you have a leftover to cancel everything you just added. Whatever that thing is, you get the answer. Sounds good? Let's try something a little bit harder. X goes to 0. Tangent h over sine 3h. Now we're familiar with the, not h, x. Now we're familiar with the trick. Sine. Okay. Then we gave it a 3x. We just got rid of it later. Sounds good? Cool. Tangent. Well, I cannot match it. I can only match sine. Make sense here? But does tangent have a sign there? The answer is yes. Okay. Then if you have a sign there, it's all right if you match it with an x and then times cosine later. Still okay? Cool. Now if you take a look, what's coming from the original problem? This is your tangent. This is your sine. You manually added a 3x, you manually added a x. So you better cancel them. To make sure they cancel and eventually give you the thing back. Once you have that settled. 1, 1, 0, cosine 0 times, well, not 0, sorry. 1 cosine 0 times 3. They cross out. What is cosine 0? 1. The whole thing is 1/3. Okay, that's basically what we need to solve this problem. It comes from a simple fact. And now every time we see sine and the inside goes to 0, we can match whatever the inside is to give it a 1. Then our energy can be focused on the last term to see what the limit is. Does this part make sense? Do we need an example for you to try? Let's try one then. Yeah. Follow what I have here. Just try to find the limit. X goes to 0. Sine square 2x over tangent 3x. Okay, follow exactly what I have here. Try it yourself. Anton?
Why do you square the 2x at the bottom? I realize the sign is squared, but why would you have to square the 2x?
Here's the thing, right? If it's sine 2x, you match it with a 2x.
Mhm.
And this goes to 1 as x goes to 0. What about sine square 2x? If you match it with a 2x square, what you're going to get is, and the inside goes to 1. Therefore, if you
Oh,
square
yeah.
it goes to 1. That's one way of thinking about it. Sounds good?
Yeah.
Another way to think about it is this. Starting from this step, we take a detour. We'll just do it and see how it goes. Good. I still have one left. Then I just do another one. That's another way to think like square is going to work. Or even if you don't do that, it's still fine. Then what you have is this. But when you do this, you are going to have a cosine 3x times a sine 2x times a 2x and 3x. So these two give you 2/3. This one gave you 1, but this one gave you 0. Because you have one more sine and 2x left. So actually, if you do things in this way, by matching only one of them, but because you have another one left, you still goes to 0. Okay, so either way, actually, it will work. And I will take either approach. Okay, the key is when x goes to 0, when you see sine x, you can almost treat it as x. That's the key. All right. Is this part clear? If the inside of sine goes to 0, you can match the same thing to make it 1. That's basically the key. Okay. Good news is, even if you have a tangent, if you split into sine and cosine, you can actually still do the same thing. I didn't do it here, but if you have a cosecant, you can probably do the same thing because there is a sine hidden there. All right. That's it. That's 3.3. Everything with regard to trigonometry. Do you guys want to continue to open a new section, or do you want to take a break? Who wants to take a break? Click yes. Everybody wants to continue? Oh, okay. We got one person. 2. So how about we call it today? We already got 15. Okay, we start this 3.4 tomorrow using the channel. So just take a break. Okay, see you tomorrow. And I will be here answering questions, of course.